Okay, in this segment, I want to first of all remind you that when conducting an F test, you no longer need to consider or think about whether you need a one-tailed test or a two-tailed test, like you did with t-tests. There's no such thing as a one versus two-tailed test. There's just simply testing the F value in the tail. So that might be a relief. And you can see that reflected in the hypotheses that we were working with before. Those hypotheses all simply said different, right? It didn't say higher, lower, faster. And the main reason for that is because you're comparing multiple groups together, right? So when you're comparing multiple groups together, it would be exceedingly difficult, if not impossible, to specify some sort of direction. So in this segment, though, since we put to rest the issue of there being a tail issue, one-tailed versus two-tailed test, in this segment, I wish to talk about choosing or introducing you to the F table in SPATS. And also walking you through how to choose the correct F value from the table. I also have a sheet or an exercise that we will do together on YouTube. Okay, couple of things. First, this I put on Blackboard. It's a pretty janky copy, so if you have your book, you might want to use your book. That is the F table, and as you can see, there's a lot of numbers on there. Maybe I'll use. Let me look up in SPATS real quick. It won't take me but a second to. All right, famous last words. Come on. Let me use the table in SPATS. I think that'd probably be better. Okay. This, starting on page 390 and going to 393. Yeah, going to 393. Those 4 pages, 390, 391, 392, and 393, those 4 pages are the F probability distribution, okay? And this is what it looks like. It is landscaped in your book, so you have to turn the book sideways in order to view it properly. A couple things I want to mention first. Okay, this is very important. These numbers in the middle portion of the table. So I'm not talking about the numbers in the margins that are blue shaded or gray shaded, depending on the amount of ink that the typesetter used when they made your book. I'm talking about these numbers in the middle. All right? These numbers in the middle. Those numbers in the middle are F values. Those values represent, as we already covered in a previous YouTube clip, the maximum amount of between group variance we could expect to occur by chance alone given certain conditions. Those values in the middle, those are F values from the table. Those numbers are the maximum amount of between group variance we could expect to occur by chance alone given certain conditions. All right? Now, you also might notice, and I'll bring it a little bit closer there, you almost might notice that it looks like, Roxy, might notice that there are, they form a grid pattern, okay? There aren't grid lines, and so I can't refer to them as cells. But there's a grid-like pattern there, and you might see some, hopefully, you can see that some numbers are in light-faced type, like this one right here, and some of them are in bold-faced, like this one right here, right? Light-faced, bold-faced, light-faced, bold-faced, light-faced appearing on top, bold-faced appearing on bottom. Why the light face and why the bold face? Or, as they said on Modern Family, why the face? WTF? the light-faced numbers, the light-faced F values, and remember, those are F values. Those are amounts of between-group variance. In fact, they are the maximum amount of between-group variance we can expect to occur by chance alone given certain conditions, and we'll talk about what those conditions are, although we are talking about one of those conditions now. Those F values, or the light-faced, are the ones that you would choose if you are conducting a test at the 0.05 level, and the bold-faced are the F values you would choose if you were conducting a test at the 0.01 level. Okay, so that's why some of the F values in the F table are light-faced and why some are bold-faced. Light-faced are F values if you're doing a test of a hypothesis at the 0.05 level. Bold-faced are F values if you are conducting a test of a hypothesis at the 0.01 level. Okay, now, in order to choose the correct F value, you will need to know two different types of degrees of freedom. Two different types of degrees of freedom. I'm going to switch over to a handout now. The first type of degrees of freedom is referred to as DF, degrees of freedom. Hopefully that's pretty, that's second nature now. DF, degrees of freedom. It's referred to as DF between/treat, sub between/treat. Degrees of freedom, sub between/treat. The formula for the degrees of freedom between/treat is K minus 1, where K is the number of groups in our analysis, the number of groups that we're comparing. K minus 1. Also, because I'm going to switch back to the table in a little bit, that's the degrees of freedom for the numerator of the F ratio. The degrees of freedom for the numerator of the F ratio. And you've already seen the F ratio here. F equals between group variance. There's a numerator and there's a denominator. So, degrees of freedom for the numerator is found K minus 1. DF, degrees of freedom, sub between/treat. K minus 1, number of groups in our analysis, minus 1. Number of groups we're comparing, minus 1. Numerator. The other type of degrees of freedom you need to be aware of is degrees of freedom within/error, also known as the degrees of freedom for the denominator of the F ratio. The formula for this degrees of freedom is n subtote minus k, where n subtote is the total number of cases in our analysis, and k is still the number of groups in our analysis. Then the third thing you need to know, we've already discussed, and that is whether you're conducting a 0.05 test, a test at the 0.05 level, or a test at the 0.01 level. Okay? So, in order to choose the correct F value, you need to know degrees of freedom for the numerator, you need to know degrees of freedom for the numerator, which is also known as DF sub between/treat, and the formula is K minus 1, the number of groups that you're comparing, minus 1. And you also need to know degrees of freedom for the denominator, also known as DF sub within/error, because degrees of freedom because the denominator is considered the error term. We mentioned that earlier. And the formula for that is n subtote minus k, the total number of cases in your analysis minus the number of groups. Now I'm going to cut this off and we will practice together finding the correct F value from the table.